In this lecture, we are going to study the production of soda ash. Soda ash is widely produced with the help of mainly two processes. First one is Leblanc process and the second one is Solvay process. And today we are dealing with the Solvay process. So soda ash is nothing but sodium carbonate, that is Na2CO3. That means there is nothing like ash in soda ash, and it finds great applications in soap, paper industry, in detergent industry, glass, paper, rayon industry. That means it has wide application. It can be used as a um, dehydrating agent because it is hygroscopic in nature. So it has got wide applications and very it is a very useful chemical. So without wasting any time, let us switch on to the raw materials which are used for its production. There are only two raw materials, that is salt and limestone. Salt, that is sodium chloride, and limestone, that means CaCO3, calcium carbonate. And coal and ammonia are used to supply gases like carbon dioxide and ammonia to the various reactors where they are required. And water, that is deionized water, simple water, is required in the various processes. So let us switch on to the process. And regarding chemical reactions, there is only a single reaction, that is calcium carbonate. When it combines with the brine solution, that is NaCl solution, it gives Na2CO3, that is soda ash, and calcium chloride is taken out as impurity. But it is not that calcium carbonate directly reacts with NaCl and it gives Na2CO3. Instead, the process occurs in a series of reactions, and these reactions cannot be just read out just now. They can be understood step by step as they are occurring in the flow sheet. So with the help of flow sheet, let us try understand the flow sheet. With the help of flow sheet, we will also understand the processes which are occurring and which are giving us Na2CO3. Now the process starts with the washing of the brine solution with its purification. Purification is required so as to eliminate the elements like calcium, magnesium, iron, and they are washed with NH3, that is reacted with the help of NH3 and carbon dioxide, and then they are eliminated as a precipitate and removed as a sludge. And then we have the purified brine solution which is pumped into the ammoniation tower. This is your ammoniation tower. Ammoniation tower, the name suggests that something like ammonia is involved. So ammonia gas is allowed to enter from the bottom of the tower, and brine solution is allowed to enter from the very top. And the reaction occurring between these two are depicted with the E. What happens? The ammonia gas present in the ammoniation tower comes in contact with the solution and it reacts with water. When it reacts with water, it gives NH4OH, that is sodium hydroxide. Ammonia is readily soluble in water, and that is why as soon as it comes in contact with water, it gives us ammonium hydroxide. Secondly, the reaction occurs with carbon dioxide and water also. The carbon dioxide present in the ammoniation tower, which is only partially supplied, reacts with the hydroxyl ion of water, and then it forms HCO3 minus, that is the bicarbonate ion. Let us see the reactions. This is your F reaction and E reaction. In the E reaction, you can see that ammonia gas is reacting with water molecule to give NH4 plus OH minus, that is ammonium hydroxide, and it is a highly exothermic reaction. The enthalpy of reaction is minus 22.1 kilocalories. The heat is very high, and this was the same heat in the production of ammonia also. Okay, when nitrogen reacted with hydrogen in the presence of a catalyst, that is Fe, this was the heat of reaction that time also. So you can imagine that this is also a very highly exothermic reaction. And the second reaction is that carbon dioxide reacts with the hydroxyl ion and it gives bicarbonate ion. So these are the reactions involved in the ammoniation tower. Now let us proceed. Now from the ammoniation tower we have Na plus Cl minus ion, that is NaCl, calcium chloride, we have water, we have NH4OH minus, that is ammonium hydroxide, we have partially in a very little amount we have bicarbonate ion, and then these are supplied to the carbonating tower. Carbonating tower is on cleaning duty when the liquor is fed into it. It has to be cleaned regularly because scales are formed because of the precipitate formation in the carbonating tower, and that precipitate formation forms scales on the inner walls of the tower, which if not removed can disturb the chemistry of the whole process. One more thing, carbonating tower is also known as the heart of the solvent industry. The reason is that the production cost of soda ash is directly affected by its designing and its working, the way it works. And uh, for the cleaning purpose, carbonating tower is cleaned for 12 hours or more after continuously working for 3 complete days. So that is, after working for 3 complete days, it has to be cleaned for another 12 hours so as to get rid of the scale formation on the inner linings of the carbonating tower. And there are 4 to 5 towers in the real industry, because so that if one has stopped working, the other is working. So this is all about the carbonating tower. Now what are the reactions occurring in the carbonating tower? In the carbonating tower, the carbonate is formed. From the name itself, we can get that carbonate, whether it is bicarbonate and carbonate, we will come to that. But a carbonate is formed, and for the formation of a carbonate, a regular supply of carbon dioxide is required. Now, where does this carbon dioxide come from? We will come to that later, but let us see that in the lime kiln, this is your lime kiln, and in the lime kiln, limestone is heated so as to give carbon dioxide, and it supplies carbon dioxide to the carbonating tower. That is, from the lime kiln, carbon dioxide is supplied to the carbonating tower. In the carbonating tower, the liquor which contains NaCl, which contains NH4OH, water, HCO3 minus ion also is fed into this, and then the HCO3 minus ion reacts with Na plus ion to give NaHCO3. The chlorine ion reacts with NH4 plus ion of the NH4 plus OH, that is ammonium hydroxide, and it gives NH4Cl, and the carbon dioxide reacts with water to give H3O3 minus ion so as to produce sodium carbonate, and this you will understand only with the help of the reactions. So let us proceed to the reaction. FGH, that is F, G and H. F, you can see, first of all, carbon dioxide reacts with hydroxyl ion of the water molecule to give HCO3 minus, and also it also reacts with the water, because water is an abundant amount in the tower, so it again reacts with that, and then it gives bicarbonate NH plus ion again. Then again Na plus ion Cl minus plus NH4 plus HCO3 minus. So these are the 4 ions in the carbonating tower now, and then NH4 plus Cl minus, that is ammonium chloride in the aqueous form. Ammonium chloride is readily soluble in water, it gets dissolved in water, and NaHCO3 is formed. I said that NaHCO3 is formed with the help of Na plus HCO3 minus, which is supplied by the carbon dioxide. Once again, I should revise this. There are 3 reactions occurring in the carbonating tower. First one, F, that is carbon dioxide gas, reacts with the hydroxyl ion and it gives bicarbonate ion. Second, carbon dioxide reacts with water molecule and then it gives H plus HCO3 minus, that is bicarbonate ion again. Now we have bicarbonate ion in abundant amount, and then further it is it is reacted with Na plus, and Cl minus and NH4 plus ions are reacted with one another, and they give NH4 plus Cl minus, that is ammonium chloride, and NaHCO3. Now this NaHCO3 is formed as a precipitate, and this is the chemical which is responsible for the formation of scales, for the formation of the impurities in the carbonating tower, because it is highly insoluble in water, whereas the ammonium chloride is soluble in water. So now our slurry, which is also known as magma in this case, okay, now it contains water, NH4Cl, that is ammonium chloride, and NaHCO3, that is sodium bicarbonate. So these are the chemical now present inside the carbonating tower, which will now come out. So this is all about the reactions occurring in the carbonating tower. Let us proceed with the next thing. Next, the liquor, that is, which is also known as slurry or magma. Okay, in this case it is known as slurry or magma. It comes and then it is sent to the rotary drum filter or rotary filter press. Now rotary drum filter or rotary filter press is generally composed of two drums. Okay, now the inside drum is contains vacuum. Okay, it is from inside, the air has been sucked out completely, and vacuum is created in the inside of the drum, in the inner drum. Okay, not on the outer one. Slurry is then supplied to it. The slurry contains solvent, that is ammonium chloride and water, the aqua solution, and as precipitate, the solid part is NaHCO3, that is sodium bicarbonate. Now this solvent is sucked by the vacuum in the inner drum, and it contains a pipe, and the precipitate of sodium bicarbonate, it is deposited on the outer part of the pipe of the drum. So you can see in this reaction, it will make it clear, in this process, in the rotary filter press, there are basically two arrows. This is your first one and this is your second one. So what is happening here, in from the rotary filter press, the solvent is sucked in from the inner drum, and it is supplied to the another reactor, which we will deal with after few seconds. And the another one contains NaHCO3. This NaHCO3, which is slaked from the top of the drum, and it is taken to the calciner. Okay, so I hope you got it. I'll revise it once again. From the rotary filter press, the solvent is taken to another reactor, which we will deal with these things later, and then the NaHCO3, which got deposited on the top, it is slaked off and taken to the calciner. Now calciner, the word comes from calcination. And what is calcination? We read two basic things in our lower classes, that is roasting and calcination. Roasting occurs in abundant supply of air. Roasting occurs when the carbonate or the limestone or any solid which is it is heated in the excess supply of air. And calcination occurs when it is heated in the absence of air. Okay, so this is your calcination. Then NaHCO3 is taken to the calciner, where it is heated to a temperature, not very high temperature, should be the less than its melting temperature, and it is heated to a temperature, then it gives CO2 gas and H2O plus the carbonate, that is Na2CO3. Let us move to the reaction part so that you will understand it better. This reaction occurs in the calciner, that is the sodium bicarbonate is heated, then it gives sodium carbonate, carbon dioxide gas is emitted, and water, and this is an endothermic reaction. This is all about the reaction occurring in the calciner. And from the calciner, the sodium carbonate formed is taken to the water cooler, where it is dried, and then your soda ash is ready to be packaged and bagged. So this is all about the soda ash process. it is formed, and now we have to deal with the carbon dioxide over here. The carbon dioxide which is emitted over here is supplied to the carbonating tower. You can see there are two arrows, one is coming from the upper one and one was coming from the bottom. So these two arrows, that is these two pipes, they both contain carbon dioxide and they are compressed and fed to the carbonating tower. The water is also not wasted, it is taken to the water cooler. Now let us come to the bottom part, which is mainly the recycling ones. Okay, so from the rotary drum filter we are getting NH4Cl, the sodium chloride. I hope you remember that our carbonating tower was it was giving us NH4Cl, the sodium bicarbonate, and water. So it was a mixture of these three, and that is why the rotary filter press has sucked all the ammonium chloride solution, and that ammonium chloride solution is then passed to a pair of recycling towers of ammonia. These are the two recycling towers of ammonia. Now the NH4Cl, the aqueous solution of NH4Cl is taken to the tower where it is steam distillated. With the help of steam distillation, ammonia gas escapes from here and then sent to the ammoniation tower. That is, it is recycled now, but there might be chances that the ammonium chloride is now still left in the tower, and that is why the ammonium chloride is taken to the next tower, which is also known as combined ammonia still tower. Now in the combined ammonia still tower, reaction occurs. So let us come to that reaction, but before that let us know something about this lime kiln. The process, everything starts from this lime kiln. In the lime kiln, coke, that is coal, and limestone, that is calcium carbonate or CaCO3, is fed. Air is supplied from beneath, and then the reaction, that is the combustion reaction, occurs. Which is that combustion reaction? Let us again understand with the help of the chemical reaction chart. B and C, that is calcium carbonate, it decomposes to give calcium oxide and carbon dioxide gas, and the coke reacts with air, with the oxygen present in the air, and it gives carbon dioxide. So basically we require carbon dioxide for the carbonating tower, and that is why the supply of the carbon dioxide is fed from the lime kiln. Now one more thing, the calcium oxide present in the lime kiln, that is the calcium oxide which is obtained with the decomposition of the limestone, is then taken to a slaker. Okay, a slaker is just a mixing machine. In this, slakes of calcium oxide is reacted with water, and then it gives CaOH2, that is calcium hydroxide, and this calcium hydroxide is known as milk of lime. Okay, you can see here that calcium oxide, it reacts with wait a minute, calcium oxide reacts with water, reaction number D, calcium oxide reacts with water and it gives milk of lime. Fine. And this calcium oxide, calcium hydroxide, that is milk of lime, is now taken to another tower, that is combined NH3 still tower, which I now discussed right now, which is fed with the NH4Cl, that is ammonium chloride and milk of lime, and the reaction between these two gives us ammonia. This is depicted by reaction number J, that is ammonium chloride reacts with calcium hydroxide, gives ammonia gas and CaCl2 as an impurity and water. So these are the reactions occurring in the combined ammonia still tower. Okay, I hope this is now very understood. NH4Cl is taken from this side, which if it is left from this tower, and milk of lime is supplied from the slaker, and then the reaction between these two gives us ammonia, and the ammonia gas escapes, and this is your recycled ammonia which goes into the ammoniation tower. So you see, The ammoniation tower then reacts with again water and gives us ammonium hydroxide, reacts with chlorine, gives us NH4Cl, and then it again comes to this. So this way your ammonia is recycled inside the Solvay industry. Now the CaCl2, which we are thinking as waste over here, it is not actually wasted. It is required, it has got same uses, similar uses as sodium chloride, and it is used as food additives, preservatives, for de-icing roads in winter, and various water treatment plants use calcium chloride. It is also a dehydrating agent. So actually this calcium chloride is not wasted. Okay, it is a very useful chemical, and then it is sent to the respective industries where they use it. It's now time to revise the process again. So the process starts with the purification of the brine solution. The brine solution is purified to get rid of the elements like calcium, magnesium, and iron, and they are removed as a sludge. The purified brine solution is then taken to the ammoniation tower, where ammonia is supplied and carbon dioxide is also supplied in a very minimal amount. The reaction occurring here is that of ammonia and water. Ammonia is readily soluble in water, therefore it gives ammonium hydroxide, and carbon dioxide gives bicarbonate ion. The reaction is highly exothermic, and that is why it is cooled to a temperature of 30 degrees Celsius and then taken to the carbonating tower. The carbonating tower is supplied with carbon dioxide from beneath, and then in the carbonating tower the chemicals entering are brine solution, ammonium hydroxide solution, and bicarbonate ion. Now, in the carbonating tower, the carbon dioxide with the help of water reacts and gives bicarbonate ion. That bicarbonate ion reacts with the sodium ion from the NaCl solution and gives NaHCO3, that is sodium bicarbonate. Also, the sodium hydroxide, it decomposes to NH4 plus and OH minus, and NH4 reacts with the Cl minus ion to give NH4Cl. This NH4Cl is readily soluble and dissolves in water, and now our slurry contains NaHCO3 as precipitate and NH4Cl in water. This is taken directly to the filter press, where the filter press absorbs the solvent and takes to another reactor, and the deposits of sodium bicarbonate are deposited on the top of the drum of the rotary filter press. From here, the deposits are slaked off and taken to the calciner. In the calciner, the calcination, that is, sodium bicarbonate is heated to a very high temperature in the absence of air, and it is decomposed to give sodium carbonate, carbon dioxide, and water. This carbon dioxide is then taken to the carbonating tower by the help of this compressor. It is compressed and cooled a little bit and then taken to the carbonating tower. The sodium carbonate is then cooled and dried, and then soda ash is ready to be shipped. After that, the rotary filter press, the solvent, we get NH4Cl aqueous, and this NH4Cl aqueous solution is steam distillated. With the help of steam distillation, NH3 gas escapes, and then it is recycled and taken to the ammoniation tower. It is ready to be used. From the free NH3 still tower, as ammonium, there are possibilities that ammonium chloride is still left, and that is why it is taken to another tower, that is known as combined NH3 still tower. Here we get milk of lime, and how this milk of lime is prepared. In the lime kiln, coke and limestone are supplied in the lime kiln, and then the reaction occurs, that is carbon, that is coke in the form of carbon, reacts with air and it gives carbon dioxide. Similarly, CaCO3 get decomposed and it gives CaO plus CO2. So this is the reaction occurring inside the lime kiln. From the lime kiln, Limekern CaO is taken to the slaker where it is mixed with water and it gives calcium hydroxide, that is also known as milk of lime. This milk of lime is taken to the ammoniation second tower where it reacts with NH4Cl ammonium chloride aqueous and gives NH3 plus CaCl2 and water. This NH3 gas escapes from the top and it is sent to the ammoniation tower, and from below we get the CaCl2 as impurity, which is not at all a waste. It is used in several industry, and that is why it is packed and sent to the industries where it is used. So we saw that how soda ash is manufactured from the two basic raw materials, that is the salt and the limestone. And this is all about the manufacture of soda ash from Solvay process.